Hey 30-2s. What we're going to look at in this video is we're still in counting methods. And in this lesson, what we're going to talk about is a new term called permutation and another new term called factorials. Nothing to worry about. Let's take a peek at these. So from a deck of 52 cards, you're given 3 different cards. So I don't know, let's say what do we got? We got an ace of spades, we got a king of hearts, and we got the joker. No, we can't do the joker, 52 cards. We got what's a good card? I don't know, we got a 10. Let's figure out how many different ways we can arrange them. Hey, there's that word I saw in the last video. How many possible arrangements are there? Okay, well, let's use the fundamental counting principle. So I'm going to draw my pretty picture. I could have 3 cards in the first spot. Once I've laid a card down, I can't lay it down again someplace else. Then 2, then 1. Okay, there's 6 ways. Now, does order matter here? Well, the answer is yes. The reason is I can tell the difference. If I line these up as ace, king, 10, that's very different than if I lined it up as king, 10, ace. So yes, the order matters. That's a really important question today. Does order matter? Were your cards identical or non-identical? They're non-identical. I can tell the difference between them. So non-identical. Do you think it would make a difference if some of the cards were identical? Well, yeah, sure it would. Like for say some reason they made a mistake in the deck of cards and they gave me 2 ace of spades that were the same, right? So say these 2 aces were the same and I had a 10. Well, I can't tell the difference in the order of how I put these 2 aces, right? I can't tell the difference. So yes, we would have less, wouldn't we? We would have less numbers of ways that we could arrange these letters or these cards. Okay, if you had 6 non-identical cards, how many possible arrangements would there be? Okay, well, I like drawing pretty pictures, right? Who doesn't? So here we go. Oh, I got 6 cards, whatever they are, then 5, then 4, then 3, then 2, then 1. Okay, that's 720 ways that I could put 6 cards in a row. Well, what if we had to arrange all 52? Okay, I could do that, I guess, right? Times dot 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 times, like, yeah, I could get this in my calculator, right? There's 52 here, then 51, then 50, and 49, all the way down to 3 times 2 times 1. Could I get that thing in my calculator? Oh, absolutely, I could get that thing in my calculator. But do I want to put that in my calculator? Absolutely not. There's no way I want to put that in my calculator. Okay, so there has to be a way, though, for us to figure that out. And here it is. What we're going to do is we're going to use something known as factorial notation to help us write these long questions like this. So an arrangement, hey, I've been seeing that word quite a bit, of distinct different objects in a definite order is called a permutation. So a permutation means order matters. One can list all of the possible arrangements, but we learned we can determine the number of different arrangements by using the fundamental counting principle. However, just like we just saw when we were arranging all 52 cards, it can be a pain in the butt. It's cumbersome if you wanted to use some better vocab than I do. So to write this in a better way, we're going to use something called a factorial. Okay, and it looks like an exclamation mark. Okay, I'm going to show you how this works. So let's go back up to the question. So looking at first E, how many ways could we put these 6 cards in a row? Well, there's a better way to do this. 6 times 5 times 4 times 3 times 2 times 1 is this. 6 factorial, like that. How many ways could we arrange all 52? Well, it starts at 52. It counts all the way down to 1. That's 52 factorial. Okay, how do I get that into my calculator? I'll show you. So here's my TI. I'm just going to go back to the main screen. So say we had 6 factorial. So first thing we do is we hit 6, then we hit math, and then you see at the top it says PROB, that stands for probability. And you see number 4, there's our factorial. Bingo, 720. Okay, what about 52? I'm going to arrange all 52 cards. Well, look at this, my friends. There's 8.06 times 10 to the 67 ways that we could arrange those cards. Yeah, that's a lot of ways, isn't it? So that is how you're going to get factorials into your calculator. Now, the proper definition of a factorial, which is on my formula sheet, looks like this. N times, we count down by 1 each time, right? N minus 2, N minus 3 times dot, 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 3 times 2 times 1. Just like that. And notice over here, N has to be greater than or equal to 0. And in fact, N has to be a whole number. Okay, so we can't have decimals in here. All right, let's play around with these a little bit. What I want you to do right now for question 1 is I want you to try to put all 4 of these things in your calculator. You're going to hit pause on the video, and when you're done, you're going to come back and we're going to see how you did. See you in a moment. Okay, I hope you hit pause and checked it out. See how you did. Okay, first one, 10 factorial. I had to use my calculator on that. I have no idea. It's a big number. So 3,628,800. Okay, B. B I'm going to do without my calculator. And I'm not trying to show off. I'm going to tell you I believe that answer is 132. Well, okay, is he right? How did he do that? Okay, here's what I want you to recognize. This is really, really important. 12 factorial is really 12 times 10, or 12 times 10. Helps if you can count, eh? 12 times 11 times 10. And I'm going to stop right there. Like it keeps going, right? It's 9 times 8 times 7 times 6, blah, 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 blah. But I'm going to stop there because what do I see in my denominator? 10 factorial. 10 factorial divides by 10 factorial. That's 1. So what do we got? 12 times 11, 132. That's how I got that answer. Okay, C. What do I get here? So what I'm going to do is I'm going to expand the larger term. So 12 factorial is 12 times 11 times 10, and I'll stop there because that's what I see in my denominator. Just like that. Again, 10 factorial divided by 10 factorial is 1. Now, 12 times 11 is 132. 3 factorial is 6. And what's that? That sounds like 22 to me without using a calculator. Okay, why is he doing this? I have a calculator. There's a reason. You'll see. Okay, last one's kind of interesting. You put 0 factorial in your calculator. A lot of people think that's going to be 0. It's actually 1. Why? What I want you to think for factorials is this is you arranging objects. Maybe think of it as being put in a row. So the first one is how many ways could I put 10 people in a row? That many ways. How many ways could I put 0 people in a row? 1 way. They're imaginary. You can't. So that's why there's such a thing as 0 factorial. So a little fact I need you to know. Okay, why was he doing this without his calculator? Well, one reason is he's crazy. The second reason is this. Simplify the following. So number 2 and 3. This is why. So what I need you to do here is I look at number 2 and I say which one, the top or the bottom, the numerator or denominator, is larger. Which one has more terms? N factorial does. So it's n times n minus 1, and I stop right there because that's what I see in my denominator. Bingo, they divide, and I'm left with n, just like that. Okay, let's try B. So B. So the top, the numerator is larger, so I'm going to count down by 1. N plus 1, n minus 1. And I stop right there because that's what I see in my denominator. Those divide out. I'm left with n plus 1 multiplied by n. And if you felt the need to, you could distribute that. Okay. Now, there is a reason why we're doing these questions, which will be clear in the video after this one, but not today. So today you're just practicing this skill. Okay, number 3, solve. Okay, well, here's this n factorial again. So I'm going to expand n factorial until I see the term in the denominator. There it is, right? Equals 20. These divide. Now I'm going to distribute. So this is n squared minus n equals 20. Hey, that looks like a trinomial. So I'm going to bring over the 20. Make sure you write equals to 0. I'm going to come up here. Guess what you're going to do? You're going to factor that bad boy. That's n minus 5, n plus 4 is equal to 0. We solve, so therefore n is equal to 5, n is equal to negative 4. Now, I'll see a lot of students write that as an answer on a test. That's not bueno because, again, think about what we're doing. We're arranging objects. I can't put negative 4 people in a line, right? They don't exist. So what I need you to do is cross off and say it's extraneous for full marks. There's your answer, 5. Check my work. All I do is I sub 5 back into my question. And now you can stick that in your calculator to check your work. Okay, last question, friends. Determine the number of arrangements. Hey, there's that word. That means order matters. That means this is a permutation that 6 students can form while lining up at the business office. Okay, why does order matter? Well, I want to be first in line at the business office, not last in line. I can tell the difference. So how many ways can we do this? Okay, I can draw a pretty picture. Right, here's me and 5 of my friends, as if I have 5 friends, right? Okay, there we go, like that. Or what we learned is this is 6 factorial. Or what we learned is we can put that in our calculator. That's 720. What I'm going to talk about in the next video is there's one last way to write this. This is a permutation. I've got 6 friends, and all 6 of us are standing in a line. That's next time. So I'll see you then.